Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together. Welcome to Properties of Special Parallelograms. The first special parallelogram you're probably going to recognize. We would call this shape a rectangle. Okay, now I know it's not a perfect rectangle because they didn't have sharp corners, but that's actually the big thing behind a rectangle is that it has four congruent angles. Okay, and because it has four congruent angles, we happen to know that those are 90 degrees because 360 split equally by 4 is 90 degrees. Our second special parallelogram is a rhombus. Okay, you have seen rhombus around you. You just may not always know that that's what it's called. So first of all, they're parallelograms, so opposite sides are parallel. I may not be doing a very good job of drawing this. I know I'm not. But it has four congruent sides. Now remember, these are both parallelograms. So one is four congruent angles, one is four congruent sides. Now, I used to teach junior high, and sometimes the kids had trouble remembering what a rhombus was, but I always kind of joked, if a rectangle and rhombus got married, their kid's a square. Because a square has four congruent angles and four congruent sides. See how it's taking properties from both? That's why I joked that the kid was a square. If you'll think about it now, think of a square box, and as you squish it, it's no longer a square, but you didn't change the side lengths, you only changed the angles. That's when you're getting your rhombus, okay? So what kind of extra characteristics are coming in with a rectangle versus a rhombus? And remember that any properties of a rectangle a square has. Any properties of a rhombus a square has. So a square has everything that the above two have. Okay, so let's think about a rectangle. I would say that is the number one shape I can draw, especially when I have lines on my paper, because it's pretty easy to keep things parallel and upright. So remember, this is 90, this is 90, this is 90, this is 90, okay? And congruent, 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 congruent. Okay, so we've got the rectangle on the left, the rhombus on the right. So what do we think? Now, they're parallelograms, so we know the diagonals bisect each other, but remember, this is a 90-degree triangle. This side okay, and this is a 90-degree triangle. So I drew the bottom both times. So the bottom matches the bottom, and we know the left and the right are congruent. We know we have 90-degree angles, so by side angle side, aren't these congruent? Absolutely. So in a rectangle, your diagonals are congruent. However, we can clearly see that these diagonals are not congruent. However, these diagonals are perpendicular. So in a rhombus, the diagonals are perpendicular, and of course they're still bisectors. Okay. And it has to do with this equidistant, because technically it's the same rules. If you go back to a kite, why are the diagonals perpendicular? It has to do with equidistant. So because this goes to the vertex, right, is equidistant, that's why the diagonals are perpendicular. And it has to do with this leg right here and this leg right here being congruent. So a square the diagonals are congruent and perpendicular bisectors. And if you think about it in a baseball diamond, absolutely. I know, baseball diamond is just a square turned 90 degrees. So all those things become true. So these are just some special characteristics that you can use either when proving something is a rectangle. Well, if you can show that you have a parallelogram with congruent diagonals, you know you have a rectangle. If you have parallelograms with perpendicular bisectors, you know you have a rhombus. If you have both, you know you have a square. So just gaining this extra characteristic of a parallelogram and this extra characteristic of a parallelogram would help you go to the next step. Okay. So I'm going to draw a shape. W, X, Y, Z. Do not ever assume anything in the pictures because the book will tell you it's not drawn to scale. All right, find W to Y. Okay, let's go ahead and focus in on just one triangle. Okay, so we can see that all sides are congruent. So if this is 5, this is 5. Okay, so we can also see that this is 5 and this is 5. So it doesn't say it specifically, but see how these are equidistant from X and Z? Because they're equidistant, this must be a perpendicular bisector, giving us our 90-degree angle. Now that we have a 90-degree angle, we also said perpendicular bisector. So if this down here is 3, then this up here is 3. And we have a right triangle. What can we do with a right triangle? We can do Pythagorean theorem. So 3 squared plus, I'm going to call this B, because there's no B's in here, plus B squared equals 5 squared. So 9 plus B squared equals 25. So B squared is 16, so B is 4. Or you know it's 3, 4, 5 because 3, 4, 5 is a Pythagorean triple. If you remember that, then that's great for your ACT. So they want to know the length of W to Y. Well, X is equidistance from W to Y, which means X to Z has to be a perpendicular bisector. Or we can see that if we were to fold this, we have 4 congruent 90-degree right triangles, right? So if this side is 4, then this side is 4. So W to Y is therefore 4 plus 4, segment addition postulate, or 8. So go ahead and draw in the shapes where you can actually write on them and label them or color parts of it in. I think is really key so that we can see stuff.
But because we had a rhombus, we knew that the diagonals were perpendicular bisectors. That's really going to be the key between getting you through this, or you can utilize the equidistant for the midpoint. So making sure you have all your key characteristics. These are just special instances. Everything else that you've learned about parallelograms is true. These are just giving you some extra oomph so that you can actually dig in there and get some special situations taken care of.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.